Okay, welcome to 5.1 Notes. Let's start off with a mid-segment of a triangle is a segment that connects the midpoints of two sides of the triangle. So if you have a triangle, for example, and let's just say, for sake of argument, that this side right here, well, let me just call it X, Y, Z. Let's just say this side, for sake of argument, again, is 10 inches long. Then if we go in 5 inches either way, say 5 inches from X to the middle, it's 5 inches, or from Y to the middle, should be the same thing, right? 5 inches each way. Then I have the midpoint, right? The middle or the midpoint of XY. And if I do the same for YZ and I find the midpoint of YZ or the middle of YZ, say that would be like right around here. For example, if YZ, say, is 12 inches long, then I go in either 6 inches from there or 6 inches from there, find the middle or midpoint of YZ. All right, so you already know the concept of midpoint. So I have the midpoint of XY and the midpoint of YZ. If I connect the two midpoints, I get the mid-segment. So that would be one of the mid-segments of triangle XYZ. Okay, so we have triangle ABC. M is the midpoint of line segment AB, and P is the midpoint of line segment BC. And those are showing the fact, right, the tick marks are showing that line segments AB and line segments BC are being cut in half by M and P respectively. So MP, line segment MP, is a mid-segment of triangle ABC. And every triangle has 3 mid-segments. Okay, so in here we have triangle ABC, and you can see that this, for example, MP is what's called a mid-segment, okay, and MN is called another mid-segment, and NP is yet a third mid-segment. So every triangle has 3 mid-segments. And so let's list the 3 mid-segments. You can even pause this presentation and try to list them right now on your own. All right, so list the 3 mid-segments. The first one, again, is MP. Line segment MP is a mid-segment. Line segment MN and line segment NP. Okay, and then we have the mid-segment theorem. So now that you know what a mid-segment is, does it have any properties or features? And yes, it does. The segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. Okay, so let's just look at MP, for example. MP is going to be parallel to AC. Okay, so those two are going to be parallel to each other. So I could even, hold on. I could even do these, right? These two are going to be parallel to each other. And the mid-segment is half as long as that same side that it's parallel to. So in other words, if this was, for sake of argument, 5 inches, then this would be 10 inches, for example. All right, give me a moment here. Okay, and this is basically just repeating the theorem again. The mid-segment theorem, the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that same side that it's parallel to. So in other words, in triangle ABC, we have line segment DE, which would be called the mid-segment. And it's going to be parallel to AC, and it's going to be half as long as AC. Or, remember, every triangle has 3 mid-segments. Or we can have line segment FG is going to be parallel to line segment BC, and it's going to be half as long as BC, as the line that it's parallel to. So you can have that situation as well. Or you can also have HI is a mid-segment, and that's going to be equal to what? Why don't you answer? I'll give you a moment. You can pause it if you'd like, or here's the answer. HI is 1/2 of the side that it's parallel to, which in this case would be AB. Okay? So remember, every triangle has 3 midsegments. Okay, so in this case, please draw this figure down. And you have UV and VW are midsegments of triangle RST. And we have that line segment RT is 90 inches, VW is 57 inches, and it's our job to find UV, the measure of length UV, and the length of RS, and the length of VS. Okay, so first of all, we have that UV and VW are midsegments. So UV is a midsegment, so it must be parallel to RT, right? UV is parallel to RT. And therefore, UV is 1/2 of RT, right? Because the midsegment is half of the side that it's parallel to. And we know the value of RT. The value of RT is 90, so we could substitute. So instead of saying 1/2 of RT, we can say 1/2 of 90, which is 45. So we have UV is 45 inches. Okay, and then VW is also a midsegment. So that is parallel to RS, and therefore is 1/2 the length of RS. So we have VW equals 1/2 of RS, and we know that VW is 57, is 1/2 of RS, and so we could solve for RS. Therefore, RS is 114 inches. Okay, let's extend this problem. Let's say we also know that line segment UW is, we'll say, 81 inches. Okay, so this midsegment UW, is 81 inches, and we know then, since it's a midsegment, it's parallel to the leg ST, right? So then we have that UW is 1/2 of ST, and we know that UW in this case is 81 inches, which is 1/2 of ST. Therefore, ST is 162 inches. So this whole leg is 162 inches. But that's not what it's asking for. It's asking for VS, which is half of that length. So what you would do is just take half of ST. VS is equal to 1/2 ST. Therefore, it's equal to 81 inches. So if this, let me change colors here. If this is 81 inches right there, so I have that little tick for 81 inches, that's also 81 inches. And that's also 81 inches. So UW, the midsegment UW, is equal to the line segment SV, which is equal to the line segment VT. So that's basically it. That's basically what you've learned today, that the midsegment of a triangle is parallel to that third side and also half the length of that same side that it's parallel to. If you have any questions or if you need any further explanations, please feel free to contact me, and it would be my pleasure to help you. Bye-bye.